So if you try running lesson 19 examples, right now it just prints an array of some integers, an array of some strings, and then it's got some circles in there also. Okay? So the code for this right here shows the nums array, the string array is called words, and now here's our first view of a circles array. So this is an array that's going to hold objects. It's not holding like a predefined int or a string or a double, anything like that. This is actually holding circles. Now, we've seen before how if you declare an int array to be size 10, it puts 10 zeros in there. Doubles would put 0.0s. Booleans would put false. So what goes into a circles array? Well, it gets what we call null. Now, null means nothing. Like there's nothing there. It's got 10 slots capable of holding circles, but there's nothing in there. In fact, just to show you a little bit about null, in the string array, I put a null value in there. See how it's blue? Like that's one of those predefined words in Java. Okay? Now this null has some weird properties to it. I'm going to show you some of those properties coming up. Okay, so to put circles in the array, what I had to do was actually like create a circle through the constructor of the circle class. So a new circle object, okay? I made it a generic circle. I never bothered to give it a name. It's anonymous. And then I put that circle into the array, and my loop went through to like different indexes. So it started at index 0, 1, 2. Now, the reason I put -2 here, I'm going to leave the last two circles as null. And we're going to see what that causes in a minute. And I just went ahead and assigned just a random radius to each circle. Okay, so we'll all have some different ones. Now, when we printed those circles a minute ago, we saw those weird memory addresses. What if we didn't want to see the weird memory address? What if we wanted instead to see like the circle's radius? Well, we learned how to do that back in chapter 15. It's a little tricky. Okay, what we learned was that if you don't want an object's memory address to a print, you go into that object and you override a special method from the cosmic superclass. Maybe you remember what that was. It was the public string toString method. If you change this special method, this method is pre-written to print an object's memory address. If instead I want it to print the radius, I'll just tell it to print the radius. Okay? So now it's going to return the radius as a string, and it's going to print the radius in place of the object's memory address. Now, this only works if I get this signature right. If I mess this signature up, like let's say I didn't capitalize the S of toString, it would compile fine on the circle end, okay? But if I ran my code, it would still print memory addresses. The reason is I didn't properly override the method. Okay, so if I change that S to a capital S, that might seem so insignificant to us. Like, who cares if that S is capital or not? Either way, it's going to compile, and either way, it's going to run. But watch now, this time it actually prints radius values. Okay, the reason is the second time I did it, I properly overrode the toString method from the superclass, the cosmic superclass, and therefore that method was properly invoked at the time of the print call. Okay? Now, sometimes you might see this in programs, and I'm just going to show it to you. It's one of these things, it's not like tested on the AP, but sometimes you'll see other programmers do this. Maybe you've seen this. It's called an @override. What that @override does is that's like a way that the compiler forces you to get the signature of the method right. If I hit compile now, it's fine. Watch what happens if I change that S back to a lowercase s and I hit compile. Now my at override won't allow me to compile. It's like a warning to me. It's saying, you're trying to override a method apparently, but you didn't. So maybe you got the signature wrong. So like the same thing would happen if like right in here, if I put an integer parameter, there's not supposed to be an integer parameter there. So the at override warns me and says, you're not truly overriding a method from a superclass because you must have messed something up in the signature. That's not tested on the AP, but that is sometimes useful to know. Okay, so I'm not going to like test you guys on that, but if you've ever seen that before and we're curious as to what that is, that's what the at override does. Okay, so we should be good now. All right. Okay, so one of the things I mentioned was comparing array values. So for example, if I wanted to compare two values from the nums array, since they're ints, I'm going to use equals equals in that comparison. And this should print, I think, false, because nums1 is 6 and nums4 is 2. So if we run this code right now, okay, it prints false. All right. What if I wanted to compare two things from the string array? So like if I wanted to compare dog to cat, well, what I would do is something real similar. I'd write out.println, but I'm going to use the words array 0 and 1. Now, I can put equals equals there, and it will compile just fine. And it will print false. And sometimes it will print true. But remember what we learned about strings. It's only going to print true if the two strings that it finds are in that string constant pool. So when we're comparing strings, we shouldn't be putting equals equals. We should be putting dot equals. And it's no different here. Even though these are coming from an array, they're still representing string objects. So we need to put dot equals when we're comparing two string values to each other. Okay? If we don't, it's not always going to work properly. So I get false here, which is what I expected. And if I compared two identical strings, I could get true. You can play around with that on your own time. Now, what if you think to yourself, okay, just to be safe, I'm always going to put dot equals. Well, maybe you've seen this before, maybe not. This is a compile error. You can't use dot equals to compare primitives. Okay, what are primitives? Primitives are like your predefined variables, such as int, double, boolean, char. Okay, so primitives for comparisons, int, double, boolean, and char. You got to use equals equals anytime you're comparing those. Okay, use dot equals for all strings and objects. Objects are anything that you create. So a circle, a bank account, okay, a student object. Anything that you create from your own class is an object. You should be using dot equals to compare. Now, remember, the dot equals method was defined in the string class. You'd have to write your own dot equals method in an object class. And you'd have to get that at override to work. Just like with the toString, it's inherited from the cosmic superclass. We'll look at that on another day, okay? But just keep in mind that you should be using dot equals in those cases. Real tricky stuff here.